Hello and welcome in this new video. In this video, we're going to see the solution of eighth question of assignment third in data science, implementing regression models, logistic and linear with the evolution of metrics. Introduction to the regression. Why do we need it? Regression analysis is a cornerstone of machine learning, allowing us to understand the predict relationship between variables from forecasting sales to predicting house price. Regression model are indispensable tools in a data scientist arsenal. Predictive power, forecasting future outcome based on this historical data. Relationship analysis, uncovering the strength and direction for connections between variable. Informed decision, providing insights that drive strategic business and research decision. Linear regression theory and application. Linear regression is a function that statically model used to establish a linear relationship between a dependent variable and one or more independent variables. It, it's often represented by the equation of y equals to beta 0 plus beta 1x and epsilon, aiming to find the best fitting straight line through a data point. Python implementation of linear regression, code snippet and data. Let's dive into a practical side. We will a popular library like NumPy and scikit-learn to implement a simple linear regression model. Observe how we define our feature X and targeted Y, train the model and make prediction. Code snip. First, we have to import a Nemify as nm from the sklearn dot linear model import linear regression. First, we assign the x and y and reshape them. Create a train equals to model equals to linear regression. Make a function and model fit. Call a fit function for x, comma y. Evaluating the linear regression loss function and RMS R2 score. Once our linear regression model is built, evaluating its performance is crucial. We use metrics like the loss function, e.g., mean squared error, and root mean squared error to measure the prediction accuracy, and R square to determine how well the model explains the variety and variability of the dependent variable. Loss function quantifies the average square difference between predicted and actual value. RMS, the square root of MSE, providing error in this unit as a target variable. R2 score indicates the proportional of variance in the dependent variable predictable from the independent variables. Logistic regression understanding probabilities. Unlike linear regression and logistic regression is used for binary classification problems. It models the probability of a binary outcome using a sigmoid function, mapping any real value number into a probability between 0 and 1. Python implementation of uh, logistic regression. Let's implement the regression for a simple classification task. We will again leverage the skit-learn to demonstrate how to fit a model and predict a class probability or a directly class label. Visualizing classification in this graph. The code snipped from the dictionary and modules. We have x and y and n informative equals to giving some values on the parameters, and x is logic stack is and mod 1 dot fit and x train comma y train for the parameter calling in the function. Evaluating the logistic regression accuracy confusion metrics. For a classification model, different evaluation metrics are employed. Accuracy give us the overall correctness, while the confusion metrics provide a detailed breakdown of true positive and true negative and false positive and false negative. Accuracy. In this graph, the, the proportion of correctly classified instance out of the total instance. In the confusion matrix, a table used to describe the performance of a classification model on a set of test data for which the true value are known. Deep dive into logistic regression matrix. Precision and recall, F1 score specificity. Beyond accuracy, other matrices provide a more nuanced understanding of our logistic regression model performance, and especially in imbalanced dataset. Precision, the proportion of positive identifications that were actually correct. Recall sensitivity, the proportion of actual positive that were identified correctly. And the F1 score, the harmonically mean of precision and recall balancing in both metrics. And specificity, the proportion of actual negative and that were identified correctly. Thank you.